Hello everyone, myself Mrs. E. Aksha Prasildarina, Assistant Professor, Department of Information Technology from Kongunadu College of Engineering and Technology. So as I said earlier, I am handling POS, that is Principles of Operating System for my second year students. Here I am going to uh, do a session on memory management in operating systems. This video we'll be discussing some background of main memory and its role in the operating system. Let's start with the role of memory in an operating system. The main memory, also known as RAM, is a crucial component of any computer system. So it is where the system stores data and instructions that are actively being used by the CPU. The operating system is responsible for managing this memory, deciding which process gets memory when they get it and how much they get. This ensures that the CPU has fast access to the required instructions as well as data, improving the overall efficiency of the system. So next comes binding of instructions and data. So in binding, basically binding refers to the process of associating instructions as well as data to physical memory locations. This can happen at three stages. One is compile time, next one is load time, and next comes execution time. In compile time, if the memory location is known in advance, absolute code can be generated. This is rare in modern systems. Next comes let me say what is load time. That is, if memory location is not known at compile time, the OS assigns the memory when the program is loaded. Okay. So next comes execution time. So in systems that support dynamic loading or relocation, binding happens during execution. So this provides flexibility and it is common in modern operating systems. So next topic is logical versus physical address space. So you have already know what is logical address. That is, logical address can be generated by the CPU, as I said earlier. Mm, The logical address is the address generated by the CPU during program execution. It is also known as the virtual address. So the physical address is the actual address in the main memory. The OS uses a component called a memory unit to map logical address to physical address. This mapping allows programs to run without worrying about the actual physical location of data in memory. So next topic is swapping. Swapping is nothing but a moving process between main memory as well as main memory and backing store. So it is a technique where a process is moved between main memory and the backing store like a hard disk to free up memory space. When a system runs low on memory, inactive processes are swapped out to the disk, and when needed again, they are swapped back into the main memory. This helps in handling multiple processes as well as ensures better utilization of memory resources. In short, we can say OS manages memory to ensure efficient execution of processes. Binding can occur at different stages, that is compile time, during compile time, load time, or in execution time. And logical address and physical address are managed through address mapping. So swapping helps managing the memory dynamically by moving process in and out of main memory. Memory is one of the most important resource in any computer system. So why? Because everything from running application to storing data temporarily depends on memory. When you open a program, it gets loaded from storage like your hard drive or anything into the main memory where the CPU can quickly access it. So efficient use of memory is essential to ensure that the system runs smoothly as well as process execute correctly. So memory management uh, is okay. Now, how does the operating system or OS manage this critical resource means by allocation, by protection, by sharing and freeing the resources. So first one is let me explain one by one. So first one is allocating. So the OS allocates the memory to process when they need it. For example, when you open a new application, the OS assigns it a portion of RAM. Next comes protecting. So the OS ensures that one process doesn't interfere with another process memory. This protection is very crucial for both stability as well as security. Next comes about sharing. Sometimes process need to share memory. The OS handles shared memory space safely, allowing multiple processes to work together like inter-process communication. We have studied this topic in second unit, right? Okay, freeing. Freeing in the sense once the process finishes, the OS frees up the memory, so it can be reused by other process. This helps in avoiding memory wastage as well as fragmentation. So all these tasks help ensures that the system's memory is used efficiently and that all process run smoothly without any interference. So in the previous slide itself, we have studied what is about binding of instructions and data. Understanding, I am keeping a tabular column for logical address, physical address, virtual address, logical address space, physical address space. Let's have a look on copy on write. That is, we simply call it as cow. So what is cow? That is copy on write. It is a method used by operating system to handle process creation more efficiently, especially when a process is duplicated, like when we use fork function system, that is a system call in Unix based systems. Normally, when we create a child process, it seems logical to make a full copy of the parent's memory, right? So, but duplicating the entire memory can be slow or waste. So, especially if the child is not going to change most of the data. So, instead, the OS uses copy on write to be smarter. So let's see how it works. When a new process is created, for example, when a parent process forks a child, the child does not immediately get its own full copy of the memory. Instead, the parent and child share the same physical memory pages. These shared pages are marked as read only. So you can think of it like this. Both the parent and child are looking at the same book, but they are only allowed to read it. They can't write anything yet. So now, as long as both processes are just reading data, everything works perfectly fine. There is no need to make extra copies, or both processes continue reading from the same shared memory, which saves both time as well as the space. But here is some tricky moment. That is, one of them tries to write to any of the shared memory pages. The OS steps in and says, wait, you want to write to this page? Then I'm going to give you your own private copy. Like that, it will give. So that specific page is then duplicated, and the writing process now writes to its own copy, while the other process still sees the original version. And that's the key idea. The copy only happens when a write occurs. Uh, that's why the name given like copy on write. Okay. Very simple diagrammatic representation of copy on write. Okay, that's all about this session. Thank you for listening. See you on the next session. Thank you.